Good afternoon, students. This is Irshad. I can help you to understand physics easily and along with the numericals. In the previous class, we have discussed about light, rectilinear propagation of light, speed of light, the speed of light in different media and different type of media like radar medium, tensor medium, transparent, opaque body, ray, convergent, divergent, parallel beam of light. This is we have learned in the last class. And now we are going to see translucent medium, a medium which allows the light only part of it. It allows only part of the light. It does not allow the light completely to pass through it. So what will you write the example for this? Oil paper, butter paper, ground glass, etc. So translucent, a medium which allows the light only part of it. Example, oil paper, butter paper and ground glass. After we will see what are the laws of refraction of light. We have two laws. The first one, incident ray, a refracted ray, and normal lies at the point of incidence on the same plane. Second, it obeys Snell's law. What is the Snell's law? N1 sin I equal to N2 sin R equal to constant. Snell's law, N1 sin I equal to N2 sin R equal to constant. We can write this is N2 by N1 equal to sin I by sin R. N1 is a refractive index of first medium, N2 is a refractive index of second medium. If the first medium is a air, the refractive index equal to 1. The second medium is an unknown, so I will write just N to place N. Then we will write here N equal to sin I by sin R. So it can also be defined as it is a ratio of sine of angle of incidence by sine of angle of refraction. So it is Snell's law. This is so N1 sin I equal to N2 sin R equal to constant, N equal to sin I by sin R. The first medium here, air. The refractive index of air is a 1. N by N2 are the refractive indices. After that, in the previous class we have learned about when the ray of light travel from optical radar medium to optical tensor medium, how the refracted ray deviates. Once again we'll come back to it. Interface or separation of the two media, and let us consider some points here. So P dash is an interface. Above is a one medium, below is the other medium. An imaginary line which is drawn perpendicular to the surface, what we can call normal, and this is the point of incidence. So incident ray it is. Okay, before that I will consider it is a radar medium. And then tensor medium. Radar and tensor. So what is the radar? Let us consider air is a first medium and water is a second medium. As we know that the speed of light in air is greater than the speed of light in water. So air is a radar, water is a tensor medium. In this case, the ray of light is moving from air to water, then the refracted ray is bends towards the normal. This is the angle of incidence, the angle made between incident ray with the normal. Angle of refraction, the angle made between a refracted ray with normal. and this is the path of the incident light ray. The angle made between refracted ray with the path of the incident light ray we can call angle of deviation, and we have seen that I is greater than angular. These two are opposite angles, this and this opposite angles, so I will write here angle I equal to angle R plus angle delta. From this, angle delta equal to angle I minus angle R. So deviation equal to delta I, angle I minus angle R. If I will consider here the speed v1, speed is v2, we will write v1 is greater than v2. If I will consider here the wavelength lambda 1, wavelength lambda 2, we will write here lambda 1 is greater than lambda 2. If I will consider the rare medium refractive index is 1, denser medium refractive index is n2, then n1 is less than n2. So in the coming class, very soon you are going to learn it, the relation between refractive index and speed of light in the given medium. Have we cleared it? This is we have learned in the past class about the rarer to denser. I mean, the first case I have taken here. This is the case. So when the ray of light travel from rarer medium to denser medium, the refracted ray is bends towards the normal. Bends towards the normal. So we have seen when the ray of light travel from optical rarer medium to optical denser medium, the refracted ray is bends towards the normal. The second case is when a ray of light travel from optical denser medium to optical rarer medium, how the refracted ray bends towards or away from the normal. We will see that. Separation of the media, A dash, imaginary line which is perpendicular to the surface, denser medium, rarer medium, point of incidence. And let us consider the denser medium is a water, rarer medium is a air, incident ray, normal represented, angle of incidence, point of incidence, bends away from the normal, refracted ray, angle of refraction, the path of the undeviated light ray, the angle made between these two is delta. So once again I will write here n is a normal, angle I is a angle of incidence, angle R is a angle of refraction, angle delta is a angle of deviation, O is a point of incidence, A dash is a interface of the two media, interface of the two media. So when the ray of light travel from rarer medium to denser medium, denser to rarer, the light ray is bends away from the normal. This is the first medium, second medium. Let us take This is the refractive index N1. N2 is the refractive index. Then what is the relation between these two? You will get it. We will get here N1 is greater than N2. Speed is V1 in denser medium. Radar medium speed is V2. What is the relation between V1 and V2? We will write here V1 is less than V2. I mean, when the light ray enter from radar medium to denser medium, the speed of the light is increases. Speed of the light increases, we have a relation V equal to F lambda, where V is the speed of the light, F is the frequency of the wave, lambda is the wavelength of light. Frequency remains constant during refraction, so we will write here V is directly proportional to wavelength. More speed, more wavelength, less speed, less wavelength, directly proportional. So we will write here lambda 1 less than lambda 2. Okay, by looking at the figure, we will write here angle I is less than angle R. Angle I less than angle R. The complete angle is R. This is the angle made between a refracted ray, the path of the incident ray is called angle of deviation. Then what we will write it is, what is the relation we will get it to write it here? So this angle, both are equal. Total angle is R, it is delta. Then what is the angle you will get it here? We will get R minus angle delta. So these two angles, opposite angles are equal. I will write here angle I equal to angle R minus angle delta. From this, angle delta equal to angle R minus angle I. How we clear it? So finally, we have two cases here. The light ray passes from radar to denser, denser to radar. Radar to denser, the speed of light is decreases. Denser to radar, the speed of light is increases. Radar to denser, the refracted ray is bends towards the normal. Denser to radar, the refracted ray is bends away from the normal. So here, this is the refracted ray. Incident ray it is. Incident ray. How we clear it? Okay. The next one is condition for no refraction. There are two conditions we have. The first one is interface represented by A dash, radar medium, denser medium, imaginary line which is perpendicular to the surface, point of incidence. Incident light ray is passing from radar to denser along the normal. Incident ray passing from radar to denser along the normal. So simply we can call normally incident. Normally incidence. Normally incidence. Then the ray of light travels in a straight line. No refraction take place. No refraction. What is the angle of incidence here? Angle of incidence. So all angles are measured from the normal. So 0. Both are parallel to each other or along the normal. When I equal to 0, the refracted ray, no refraction. So moving straight line, R also 0. And what is the deviation here? Deviation also 0. But small here. The speed of light changes little in denser medium. The speed of light changes little in the denser medium. I think I will clear it. So this is the point of incidence. Normal incidence, no refraction take place, I equal to 0, R equal to 0 and delta equal to 0. Similarly, if I can go with denser to radar along the normal, again no refraction take place. I think you got it. Second one, interface represented by A dash, normal to the surface, point of incidence, normal. Okay, here we have taken n1, n2 refractive indices. So n2 is greater than n1. I mean, it is a rarer. This is the denser. Rarer and denser medium it is. Here I will take n1, n2, but n1 equal to n2. Refractive indices are equal. What is? Refractive indices are equal. When refractive indices are equal, no refraction takes place. If it is a straight line here, the ray of light passes. It passes without any deviation, passing from straight line, but small, very small, little changes in the speed of light. But no refraction takes place. No refraction take place. So there are two conditions. The first one is normally incidence. The second one is the refractive indices are equal. How we clear it? I think better to understood it is. Only there are two conditions for no refraction take place. The first one is normally incidence. The second one is refractive indices are equal. Let us see the 4 examples. 1, 2, 3, 4 examples. N1 is the first medium, N2 is the second medium for everything. N1, N2, N1, N2, and it is also N1 and N2 here. N1, N2. So what is the condition I have taken? N1 is greater than N2. I mean, N1 is a denser medium. N2 is a rarer medium. So when the ray of light travels from denser medium to rarer medium, the refracted rays bends away from the normal. Definitely, without fail, the angle of refraction is greater than angle of incidence. I mean, R is must be greater than 15 degrees. Case 2. First is a rarer, second is a denser medium, but I have taken N1 equal to N2. Both the refractive indices are equal. The light ray travels in a straight line without any deviation. So simply I will write here no refraction. Third case, first medium is the N1, second is the N2. N2 is greater than N1. So N1 is a denser medium. Sorry, N1 is a rarer medium. N2 is a denser medium. Denser medium. This is the rarer medium. Rarer medium. So when the ray of light travels from optical rarer to optical denser, the refracted rays bends towards the normal. In this case, angle I is greater than angle of incidence 10. It must be greater than refracted angle. This is the refracted angle here. This is the refracted angle. Case 4. It is incident normally perpendicular to the surface. N1 N2 are same. N1 is greater than N2. N1 is less than N2. For these 3 cases, no refraction takes place. No refraction. How we clear it? So once again we will see what we have learned in this session. So first we started with translucent. It allows only part of the light, and Laws of refraction. There are two laws. Incident ray or refracted ray, normal, lies at the point of incidence on the same plane. Second, it obeys the Snell's law. N1 sin I equal to N2 sin R equal to constant. If the first medium is the air, the air refractive index is 1. So the refractive index defined as the ratio of sin of angle of incidence by sin of angle of refraction. And the ray of light travel rarer to denser, denser to rarer. There are no conditions, there are two conditions for no refraction take place. The first one, normal incidence. The second, both refractive indices are equal. I think have you understood? Thank you.